Good afternoon, everyone. My name is Rehan Shivani, and today I'm going to present my presentation on a self-hosted sandbox server. These are the table of contents. So let's begin with the introduction. The goal of this project is to set up, configure, and use an old desktop PC as a headless Linux microserver. For this project, we'll be adding VM layers and SSH tunneling using hypervisor software. We are doing this for We're doing this so we can create a sandbox testing environment that would be safely contained using the above mentioned virtual machine layers. So the existing system as of today, there are a few systems that allow us to host a sandbox testing environment. Obviously there are CSPs, cloud service providers like Microsoft's Azure, that allow us to execute such things, but most CSPs don't really allow this and goes against the regulations and rules. Also, going this route can be very expensive. The other alternatives to using an old PC as a headless server is using a single board PC like a Raspberry Pi. So, what are the problems with the existing system? To be honest, the problems with the existing system are few. We live in a modern age, and there aren't many flaws with the existing system, apart from cost and infrastructure, and obviously the rules and regulation imposed by the CSPs. The proposed system, like I said earlier, aims to repurpose an old PC into a sandbox server. So the system that I'm using currently is a 32-bit Pentium Core 2 Duo, which is a fairly old PC. It has just 2 gigabytes of DDR2 RAM and it still works. So when we install Ubuntu server, we need to make sure we set up SSH and do not use a desktop environment. The power cost calculated for my system is 50 cents a day. So the architecture of the project, the server, since it's quite old, is 32-bit i386, upon which we are running Debian based Ubuntu server, which is an older version of Debian and Ubuntu, Debian 10 Buster or Ubuntu 16 Xenial, which is only two versions of Debian/Ubuntu that still support 32-bit processors. Once we have a host operating system, we can create or install a hypervisor software like VirtualBox or ESXi to run the virtual machines. This is the data flow diagram of the project. So the hardware requirements for this project, so I'm at the bare minimum, which is a 32-bit Core 2 Duo Pentium processor with 2 GB of RAM, a basic power supply, and a hard drive. This is the timeline of the project. As you can see, the inception was in this year, last year's 2021. So over the period of the last 4 months, I have been through trial and error improving the system, which I'll be showing later on. These are the screenshots. So this is the first figure, which is just over an SSH connection. This is the CLI input window. This is VNC over SSH. So you have a XFCE's graphical user interface desktop. So when we talk about impact on society, with the help of this project, I do believe we can upcycle and recycle a lot of old PCs and repurpose them as many a server. We can use them from everything from file transfer protocol servers to self-hosted local websites. So the pros and cons of this project. So the pros, obviously, self-hosted. That means you have full control over the hardware. and you know exactly what's going on. It requires a lot of maintenance. That's a direct con of having something self-hosted. Very easy to break it. Yes, if you're not careful, you can corrupt the entire file system very easily. Super fast connection because it's plugged into your home network. It is fully customizable. But it takes up data from your home internet plan. If you do not have an unlimited connection, this can be expensive when it comes to internet. There is no redundancy with the system at all, unless you put in the effort to make it redundant, and it's completely dependent on the person who set it up. It's only as good as you are. If you know what you're doing, you can set this up. Like I could not set up RAID, so there's no redundancy on this system. In conclusion, I'd like to address all the future work that is yet to be done. As of now, we have a stable system which does everything that is intended to do when I started this project. But however, there are still a lot of things we can improve. Obviously, hardware improvements can be made since this is a very outdated system. Also, improvements on the software side can be made. Like I said earlier, you can somehow configure RAID if you have multiple hard drives for redundancy. The sandbox part of the virtual machine still needs to be encrypted, but apart from that, everything seems to be working fine. The references. Thank you.